Hello and welcome to a new video of Tech Talks. Today we are going to talk about Hadoop in cloud application and development. To understand Hadoop, first you have to understand what is big data. Analytics provides an approach to decision making through the application of statistics, programming and research to discern patterns and quantify performance. The goal is to make decisions based on data rather than intuition. Simply put, evidence-based or data-driven decisions are considered to be better decisions. Analytics replaced hippo effect, that is, highest paid person's opinion, as a basis for making critical decisions. So, what is the difference between big data and what we have traditionally called analytics? The difference is massive volumes of data that we now have access to, the speed at which data is accumulating, and the variety of different data points. Volume of data, according to Andrew McAfee and Eric Brynjolfsson. As of this year, the amount of data being created is in the range of a few exabytes and doubles every 40 months. So more data crosses the internet as per date today and was stored in the entire internet 20 years ago. The amount of data available is staggering. Velocity of data. The speed at which data is created is sometimes more significant than the amount of data, and the ability to react to large amounts of data is real or near real. Time equates with agility today. The example often cited is that of the MIT Media Lab using location data from mobile phones to determine the volume of shoppers at Mackey's parking lot on Black Friday. The goal was to estimate the retail sales ahead of Mackey's actual recording those sales. Analysts kill for this sort of predictive edge. Variety of data. The advent of social media changed the data landscape significantly. Today, we have many relatively new sources of data. When we think of traditional data points or those that we are found in relational databases, we don't tend to consider photos, tweets, status updates, location or GPS coordinates, which are relatively new data points. What is Hadoop? Apache Hadoop is an open source software framework used to develop processing applications which are executed in distributed computing environment. Applications built using Hadoop are run on large datasets distributed across clusters of commodity computers. Commodity computers are cheap and widely available. These are mainly useful for achieving greater computational power at low cost. Hadoop is a series of related projects, but at the core we have the following modules. Hadoop Distributed File System, also known as HDFS. This is a powerful distributed file system that provides high throughput access to application data. The idea is to be able to distribute the processing of large data sets over clusters of inexpensive computers. Hadoop MapReduce. This is a core component that allows you to distribute a large data set over a series of computers or parallel processing. Hadoop Yarn. This is a framework for the management of jobs, scheduling, and the management of cluster resources. Similar to data residing in a local file system of a personal computer system, in Hadoop, data resides in a distributed file system which is called as Hadoop Distributed File System. The process model is based on a data locality concept, wherein computational logic is sent to cluster nodes containing data. This computational logic is nothing but a compiled version of a program written in a high-level language such as Java. Such a program processes data stored in Hadoop, HDFS, Big Data, Hadoop, and Cloud. In a recent article for application development and delivery professionals, Gualtieri and Juana wrote that Hadoop is unstoppable. In their estimation, it is growing widely and deeply into enterprises. In their article, they go on to review several vendors including Amazon, Cloudera, IBM, and others. They conclude IBM is a leader from a market presence, the strength of the big data insight Hadoop solution and strategy perspective. Hadoop ecosystem and components. Below diagram shows various components in the Hadoop ecosystem. Apache Hadoop consists of two sub-projects. Hadoop MapReduce. MapReduce is a computational model and software framework for writing applications which are run on Hadoop. These MapReduce programs are capable of processing enormous data in parallel or large clusters of computational nodes. HDFS, Hadoop Distributed File System. HDFS takes care of storage part of Hadoop applications. MapReduce applications consume data from HDFS. HDFS creates multiple replicas of data blocks and distributes them on compute nodes in a cluster. This distribution enables reliable and extremely rapid computations. Although Hadoop is best known for MapReduce and its distributed file system. HDFS. The term is also used for a family of related projects that fall under the umbrella of distributed computing and large-scale data processing. Other Hadoop-related projects at Apache include Hive, HBase, Mahot, Scoop, Flume, and Zookeeper. Hadoop architecture. This is a diagram of high-level Hadoop architecture. Hadoop has a master-slave architecture for data storage and distributed data processing using MapReduce and HDFS methods. Name node. Name node represent every file and directory which is used in the namespace. Data node. Data node helps you to manage the state of an HDFS node and allows you to interact with the blocks. Master node. The master node allows you to conduct parallel processing of data using Hadoop MapReduce. Slave node. The slave nodes are the additional machines in the Hadoop cluster which allows you to store data to conduct complex calculations. Moreover, all the slave node comes with task tracker and a data node which allows you to synchronize the processes with the name node and job tracker respectively. In Hadoop, master or slave system can be set up in the cloud or premise. Features of Hadoop. It is suitable for big data analysis as big data tends to be distributed and unstructured in nature. Hadoop clusters are best suited for analysis of big data since it is processing logic, not the actual data, that flows to the computing nodes. Less network bandwidth is consumed. This concept is called as data locality concept, which helps increase the efficiency of Hadoop-based applications. Scalability. Hadoop clusters can easily be scaled to any extent by adding additional cluster nodes and thus allows for the growth of big data. Also, scaling does not require modifications to application logic. Fault tolerance. Hadoop ecosystem has a provision to replicate the input data onto the other cluster nodes. That way, in the event of a cluster node failure, the data processing can still proceed by using data stored on another cluster node. Network topology in Hadoop. Topology, or the arrangement of the network, affects the performance of the Hadoop cluster. When the size of Hadoop cluster grows, in addition to the performance, one also needs to care about the high availability and handling of failures. In order to achieve this, Hadoop clusters formation makes use of network topology. Typically, network bandwidth is an important factor to consider while forming any network. However, as measuring bandwidth could be difficult, in Hadoop, a network is represented as a tree, and distance between nodes of this tree, number of hops, is considered as an important factor in the formation of Hadoop clusters. Here, the distance between two nodes is equal to the sum of their distance to their closest common ancestor. Hadoop cluster consists of a data center, the rack, and the node which actually executes jobs. Here, data center consists of racks and rack consists of nodes. Network bandwidths available to process varies depending upon the location of the processes. That is, the bandwidth available becomes lesser as we go away from processes on the same node, different nodes on the same rack, nodes on different racks of the same data center, nodes in different data center. That's it for the video. Thank you for watching.